Okay, next we consider another additional example. Okay, so here is a long circular pipe with outside radius R to be outside radius, which means from this one to here is R. So we have R from here to here. And carry a uniform distributed current into the page. So we have some cross indicate the current going into the page. So a wire runs parallel to the pipe at the distance of 3R. So from this point to this wire, we have totally 3R, 1R, 2R, 3R. 3R from center to center. So find the magnitude and direction of the current in the wire such that the net magnetic field at point P, this point, which means a BP, P here, has the same magnitude as the magnetic field at the center of the pipe, which means this point, BC, but it's in the opposite direction. So with the same magnitude, but opposite direction. Okay, so first we consider BC. So for BC, first maybe we can assume the direction of the wire is the current direction in the wire is out of the page. We may assume it. Actually, you can assume it is into the page, then the polarity of each term may be different. So now we consider the direction of the direction of the current in the wire is out of the page. So for this wire, generating the B field at point C will be nothing but this is a long wire. So we will use mu0 IW. We have IW here. We have I here. Actually, we need to find IW. We need to find the magnitude and direction of the current. Yeah, here. So actually, we need to find IW. And then over 2 pi, the distance. The distance from this point to this point is totally 3R. So we have 3R here. So this is the part of the magnetic field generated by the wire. And for the one generated by this hollow wire, this should be 0. This should be 0. Because you can simply apply a ampere loop here, and then you assume the radius is very, very small, and it encloses nothing. Then due to the symmetric, all this stuff will generate no B field at this point. No B field at this point. So this hollow wire generate no B field at this point. So we have plus 0 here. And next, we consider the magnetic field at point P. So for the wire, it should be mu0 IW over 2 pi R. So the distance between the wire and point P is only capital R. So we have R here. And for this one, it is going into the page. So it will generate a B field point to the onto the right side, this one you check. Yeah, actually, you can determine the direction like we have the wire here. We have the wire here. If we assume the current is going out of the page, then at point P, the B field should point to the right side. The right side, BPW due to the wire. And here, let me see. So if we consider this wire, is going into the page, so we use right hand rule to follow the direction. So BP is type also point to the right side. So we have a mu0 I over 2 pi 2r. 2 pi 2r. Yeah, and it should be like mu0 IW over 2 pi r plus mu0 I over 4 pi r. And of course, with this condition, they have the same direction but opposite direction. They have the same magnitude but opposite direction, which means BC equals minus BP. BC minus due to this condition. So here we have mu0 IW over 6 pi r. Because here it is actually mu0 IW over 6 pi r. We have a 2 times 3 here, and then equals minus BP. So we have minus sign there. So it should be a minus mu0 IW over 2 pi r minus mu0 I over 4 pi r. Should be like that. Yeah, should be like this one. That's BC equals minus BP. So yeah, now we can just move this term to the left side. So we will have 1/2 plus 1/6. So it is a 2/3 mu0 IW pi r equals minus mu0 I 4 pi r. So in this case, pi and pi can be cancelled, mu0 and mu0 can be cancelled, r and r can also be cancelled. So finally, IW is minus 3 over 8 I. And we know that I is 8 VBA. So we have minus 3 over 8 times 8, which is a minus 3 VBA. Of course, we assume the wire is out of the page. So actually IW is into the page.